A ratio table is a table whose columns are filled with pairs of numbers that have the same ratio. If you look at the table which describes the recipe for oobleck, we have 2 cups of water and 4 cups of cornstarch, and 6 cups of water for 12 cups of cornstarch. These ratios can be written as 2/4 and as 6/12. 2/4 and 6/12 are equivalent ratios because the fractions 2/4 and 6/12 are equivalent fractions. Ratio tables contain patterns that can help you solve for missing ratio values. For example, to move horizontally to the next column in my ratio table, I must multiply or divide by the same number. To go from 2 to 6, I multiplied by 3, and to go from 4 to 12, I multiplied by 3 as well. To determine my missing value, I must first determine how I got from 12 to 48, and do the same to my numerator. I know that 12 times a number must equal 48. To figure out the missing number, I can fill out a fact family, and I know that 48 divided by 12 equals 4. So 12 times 4 equals 48. I must also multiply my 6 by 4 because 6 is in my numerator. 6 times 4 is 24. So my equivalent ratio is 24/48. Another strategy is to look for vertical patterns in my ratio table. To get from 2 to 4, I multiply by 2. To get from 4 to 2, I divide by 2. Another strategy is to look for vertical patterns. Another strategy for solving for missing values is to look for vertical patterns in your ratio table. To go from 4 to 2, I divided by 2. So to go from 48 to my missing value, I would also need to divide by 2. 48 divided by 2 equals 24. Patterns across multiple steps can also be used, as long as you make sure that you use the same pattern for the same number of steps. So for example, to go from 4 to 48 is 2 hops over my vertical lines. And that means that I must go 2 hops at the top as well. Keep looking for patterns that will help you solve for missing values in your ratio tables. Sometimes it is challenging to find the patterns in a ratio table. In this case, we will use scaling instead. Multiplying or dividing 2 related quantities by the same number is called scaling. Sometimes you may need to scale back and then scale forward again to find an equivalent ratio. Look at the picture of the flower. If I move my picture to scale, that means that I either increase or decrease the height and the width by the same amount. To use scaling, I'm going to try to figure out how to get from 14 to 49. I like to think of this as 2 sides of the river, and I need to hit a stepping stone before I can get to the other side. This stepping stone is going to be any common factor that 14 and 49 share. One common factor of 14 and 49 is 7. Now I've got to find the relationship between 14 and 7 and 49. When I moved from 14 to 7, I divided by 2. So for my denominator, I must also divide by 2. 8 divided by 2 is 4. So 7/4 is equivalent to 14/8. Now I must determine the relationship from 7 to 49. 7 times 7 equals 49, so I must do the same to my denominator. 4 times 7 is 28, so 49/28 is equal to 7/4.